In this chapter, we will learn about a new distribution called the normal distribution. Now, normal distributions are extremely important in statistics, and they're often used in natural and social sciences for real-valued random variables whose distributions are not known. Now, one reason for their popularity is this theorem called the central limit theorem, which states that under Mao conditions, the mean of a large number of random variables independently drawn from the same distribution is distributed approximately normal. Now, this is regardless of the form of the original distributions where the random variable comes from. Now, you will see later in this chapter why this theorem is so powerful. Here in the notes, you see the pictures of the two mathematicians that has contributed greatly in the development of normal distributions, Gauss and Laplace. Now, before we start defining what a normal distribution is, now let's take a look at some new terminologies. Now, what is a continuous random variable? Now, in our previous chapter, we learned about discrete random variables. Now, examples are the binomial distribution, the Poisson distribution, and we call these distributions discrete because we can count. We can count 1 head, 2 head, 3 heads, 4 heads out of 4 tosses of a fair coin. Now, but in real life, we often deal with quantities that are measured on a continuous scale. Now, examples of continuous random variables are height, weight, amount of alcohol in a person's blood, and even the speed of a car. For example, the heights of members of a population measured will not follow discrete values. The variable can take any value in an interval from A to B. Now, the next terminology that we want to look at is this thing called density curves. Now, when we analyze data, one of the most common form of graphical representation of information is the histogram. And I'm sure all of us have drawn histograms before, especially in project work. Now, in your notes, you see a relative frequency histogram, the one in yellow here. Now, if we imagine that each bar has got a very small breadth, then we can actually approximate the histogram by a smooth curve. Now, the one in red in your diagram is the smooth curve that I'm talking about. Now, this curve is what we call the density curve of the distribution.